Graphical transformation, first one. The first one is fx plus or minus a. That means it will shift up, along, up and down, along y-axis. That means a plus for the up one and minus for the down one, ne negative one, negative for the down one. For example, you have fx equal to e to the power of x. You know the graph. This is your x-axis. This is your y-axis. This is the point 0, comma 1. Now, suppose I write fx is e to the power of x plus 1. Let me write this. Yes. Let me write this with a different color so that I can sketch the graph. Fx is equal to e to the power of x plus 1. So now it will go from 0, comma 2. It will shift everywhere by 1 unit, by 1 up. It will go. This is e to the power of x plus 1. This is e to the power of x, the white one. And suppose I write fx equal to e to the power of x minus 1. So now it will go like this. This is the point now 0, 0. Now it has been shifted by 1 unit. So this is e to the power of x minus 1. I hope this one is clear. The next one. Let's come down to the next one. Yes. Second, fx plus or minus a shifts the the graph, graph to the left or right of the x-axis, along the x-axis rather, along x-axis. Plus will shift it to the left and minus will shift it to the right. For example, let us take fx is equal to mod x. This will go, this is your x-axis, this is your y-axis, this is 0, 0. This is the point 0, 0. This is actually x minus 0. The point is 0 basically. This point is 0 basically. That is your coordinate 0, 0. Let's write only 0. That would be better. And let's now draw the graph. For this, we already know this is the graph. Now for fx equal to x minus 1. So you are seeing a minus here. Shift it to the right. Shift it to the right. So you put a 1 here. And this is the way the graph grows. Now you have, say, fx equal to mod x plus 1. Now you can see a plus, plus shift the, with a, this will be the graph. Will shift to the left. This will be the graph. Now the second is done. Now let us take another one. Yes. Third one. See, fx, if fx, sorry, wait. Fx is third one. If fx is written as afx, this will, and a is greater than 1, then it will stretch the graph along the y-axis. Stretch, wait a minute, stretch the graph greater than 1, stretch the graph along y-axis, and if a is less than 1, rather I should say, if I write it in this manner, this will be a better way, keeping a greater than 1, you write it as 1 upon a fx, then it will shrink this is stretching, this is shrinking along y-axis. Now see this. Let me give you an example. Let me take one example. Here it is. Y equal to sine x and y equal to say half sine x. See, Your sin x graph is like this. This is your 1 and this is your minus 1, y equal to 1, y equal to minus 1. Your sine graph goes like this. This is 0, pi, 2 pi, like this, 0, pi, 2 pi. And in case it is halved, so what will happen? At this, let me write it in this color, half. Let me write it in this color, sine x. So this will be, now this is your this will shrink the graph. See, this is half and this is minus half. Y equal to minus half. Now it will go like this, pass through it, and then go like this way. This is the way it is. Now similarly, if I have, let us take this. Let us take this. For this was for shrinking. Now let's take one for stretching. Now you have y equal to sin x, the other y equal to 2 sin x. Now see, y equal to sin x is like this. This is your y equal to 1 and this is y equal to minus 1. Sorry, wait a minute. Y equal to minus 1. This is your x-axis. This is your y-axis. This is your y equal to minus 1. Now see, now your graph goes like this. And this goes like this way also. Wait a minute. This side I made a mistake. Wait, let me draw this clearly. Yes, this way it goes. Now when I use this, when I multiply by 2, now this is the line y equal to 2. This is the line y equal to minus 2. Now this will be going like this, going like this, and going till here. This will go till here. It will go till here, and then it will come down till here, till here. This is the thing I mean by this. Now the next one is if it is this way. This is the third one, the fourth one. I'm talking about the fourth one. The fourth one, if you take fx equal to is changed by fax. A is now inside. If a is greater than 1, a is greater than 1, then it shrinks. Shrink along the x-axis, along x-axis, and a greater than 1. I forgot to write. And fx is replaced by f 1 upon ax. Then this will stretch. Wait a minute. This will stretch along the x-axis. Now see the graph like this. This is any graph. This is your x-axis. This is your y-axis. This is your, suppose, let me take one example and then I'll tell you. See, this is your y equal to 1, y equal to minus 1. And this is y equal to 1. The normal y equal to sin x graph, goes like this. I'm taking this much only. Now suppose I take y equal to sine 2x. So now this point is basically 0. This is pi. And this is your, wait a minute, let me write it in this manner. Wait a minute. This is your pi. This is your pi by 2. Now when you write 2 inside, now this will shrink. So this will now be like this. It will come here. Now the 0, wait a minute, just a minute. This will shrink like this. It will be here. It will be here. See, now it will be here and it will be here like this. It will shrink. See, it has earlier this was the total width of this. Now the width has become this. This has shrunk. This has shrunk. Now let's take another one. This is the fourth one. Now we will take the fifth one. We will take the fifth one. The fifth one is very simple one. Wait. Yes. The fifth one. The fifth. Wait. Let's take the fifth one. Suppose fx is replaced with f minus x. F minus x. That means just reflect the graph about the y-axis. Reflect the graph about wait about y-axis, about y-axis. Now see, supposing, right, this is exactly reflect about the y-axis. Suppose I have this y equal to e to the power of x. You know the graph of this x-axis is the y-axis. You know e to the power of x is like this. Now suppose I write y equal to minus e to the power of x. So you will do one thing, just change, reflect it along this will be your mirror. Then you will reflect it along this y-axis. This is your e to the minus e to the power of x, and this is your e to the power of x. This is the way. Similarly, if you take one more, y equal to log x. You have y equal to log x. The graph of this is something like this. This is log x, log x. Now this is your x-axis, this is your y-axis. Now if I write y equal to minus log x, that means I want a reflection along the y-axis. So I'll get like this. This is my y equal to log x. Let me write, wait, just a minute. This is my minus log x, minus log x. This is the way it is. Now the sixth one, sixth, yes, the sixth one is if fx is written as minus of fx, then what you have to do, just reflect about the x-axis. That was reflect about the y-axis when it was inside. This is reflect about x-axis. Now you have, suppose y is e to the power of x. So you know the graph how it is. It is something like this. This is e to the power of x. Now if I write y equal to e to the power of minus x, you need to just reflect. This is your x-axis and this is your y-axis. Reflect it along the x-axis and you will get e to the power of minus x. Similarly, if I have another example, if I have y equal to log x, you know that log, this is your x-axis and this is your y-axis. So your log x goes like this. Now y equal to minus log x would be like this. This line will be reflected here. It will come here. Wait, let me rub this. Now this was your log x, something like this. So minus log x would go somewhat like this. This is minus log x. And this is your plus log x. Now let us see. Now you have this, you can have this type of a graph. Let me drag it down. Wait a minute. Here, this is, I think, this is the seventh one. Suppose fx is written as minus f of minus x. So for example, you will first take the image about the y-axis. Because of this, you will take image about, reflect about the y-axis. Let me write reflect about the y-axis. First thing that you will do, first reflect about y-axis. Second, After that, reflect about about x-axis. Now take an example, y equal to e to the power of x. You know this is to be drawn like this is your x-axis. This is your y-axis. E to the power of x is drawn like this. Suppose now I take y equal to minus e to the power of minus x. So first you take the reflection about the y-axis. Y-axis reflection, this is your e to the power of x. Wait, let me write. This is e to the power of x. The first reflection is about the y-axis is this. And this is e to the minus e to the power of x. And then you take the reflection about the x-axis. That means this will come like this. That is minus e to the power of minus x. This I have, you got it. Now the next one, the eighth one. Eighth one, we have the eighth one. Now you have the eighth one. Wait, yes, the eighth one. Suppose eighth one, you are writing fx is written as fx of mod x. Then what you have to do, you have to reflect uh, the portion of the graph below the x-axis, x-axis, below the x-axis, about the x-axis. That means suppose you have a graph like this, going like this. This is some graph, fx. This is your x-axis. Sorry, this will go like this. And this is your y-axis. Now I write mod of fx. This mod of fx, this graph will now become, this is your x-axis, this is your y-axis. This much will be there, this much will be there. So this much portion will now go to this much portion. Sorry, wait, this will go to this portion, and this portion will go to this portion. Like for example, let me take one more example. That is y equal to sine x. I have y equal to sine x. So you know the graph of sine x like this, x-axis, y-axis. It goes like this. Let me take this much only. Wait. Let me take this much only. Wait. Let me take. Okay, this much. And I take this much. Now when I write mod of this graph, when I write mod of sine x. Wait, let me write with a different color. I write y is mod sine x. That means I'm talking about this way. Now this is your x-axis, this is your y-axis. Now this one portion will remain as it is. Now this portion will go up, and this portion will also go up, and this will remain as it is. This is the way it will be. Now this have you understood? Ninth one, you have fx is f mod x. So neglect the portion of the graph, neglect the curve, I should say, curve for x less than 0, and take the image, take the image, take the image, take the image of the curve for x greater than equal to 0. Take an example, y equal to e to the power of x. Now this is your x-axis, this is your y-axis, this is e to the power of x. This way is e to the power of x. Now, if you take y equal to e to the power of mod x, what you do is that you neglect this much portion from here, and then you take the reflection. See, you take the reflection of this much portion, here. You take the reflection of this much portion here. So this becomes your, this yellow color. Now the yellow color is e to the power of mod x. Similarly, if you take for another example. Let me take another example in this. Uh, yes, let me take another example. Yes, I have y equal to, wait a minute, y equal to log x. And in this we know the graph of this is x-axis, this is y-axis. This is your log x, log x. Let me write this a little bit here. Wait a minute. Y equal to log x. This is my second graph. This is my second graph. Y equal to log x. Now you have, there is no x portion. यहाँ पे कोई x portion, negative portion नहीं है x का. So I have to take the reflection of this much portion only. That is, यहाँ पे x का कोई portion नहीं है. There is no negative portion of the x-axis. Negative portion in the x-axis. So I'll take the reflection of this much portion here about the y-axis. This is your y equal to, the yellow color is log mod x. This is your, this yellow color is your log mod x. Next. Now you have, let us have one more. 10th. Let us have one more. 10th. This is fx is to replace with f mod x. Sorry, mod x. Mod x. F mod x. Then whole mod. So what you do is that you have, suppose a graph like this, y equal to fx, you have like this. Sorry, not y equal to, but take fx, some graph like this. This is your y-axis, this is your x-axis, and some part of the graph is somewhat like this way, and this way, and this way. Let's terminate this way, this way, this way, and then this way. So what you do is that the first is you take the you take the image of this portion. You neglect this portion. You neglect, because there is the mod x inside. So neglect this portion. So what you will get an image as, the image would be somewhat like this. Somewhat like this. Check the reflection this way and then this way. And then there is a mod outside also. So now what you are left with, now this color, this yellow color now will become blue color, and this part of the yellow color and this part of the yellow color will be reflected here, here, and this will become the blue color. So now this blue color is the final answer. The blue color is the final answer. You will neglect this portion, you will neglect this portion now. This is what it means. Now let's come to the 11th one. Let's come to the 11th one, and I think this is sufficient for the 11th one. Now see the 11th one. Suppose you have, now you see some clarity, the 11th one. You need some clarity here. Mod y equal to fx. Till now I was writing only fx. Now see, what they are trying to say is, whatever fx will be, that means whatever fx will be, you will take only the positive values. Why? It will only be valid for only positive values. So in this case, what you need to do, the first step, remove the graph, the portion of the graph below the x-axis, below x-axis, number 1 point. Second, plot the remaining graph, plot the remaining graph, the remaining graph, the remaining graph, remaining portion of the graph, rather, portion of the graph, and take the reflection about, take the reflection, take reflection about x-axis. See one thing, do not confuse this. Mod y does not imply fx is mod, because they're equal. This is some function, and this means This basically means, this condition basically means, let me explain you here. That means mod y is always positive. So, if you have fx less than 0, the graph won't exist. Graph won't exist. Graph won't exist. It will exist only because if fx is greater than equal to 0, then this so so mod y would be given as mod y equal to fx would imply y is equal to plus minus fx. That means you will always have this. See, देखो ये fx अगर less than 0 है, I'll do with an example. See, suppose I have this example. I have this example. I have this example. Let us say this curve. Let me take this type of a curve again. X-axis, y-axis. Now I have this type of a curve. Now what I will do is that I said in this case, this is y equal to fx. Now they are saying mod y, I want mod y fx. Wait a minute. I want mod y, I want mod y equal to fx. This I want, right? So I'll neglect the portion below the x-axis. This whole portion will be neglected. So you neglect this portion. So what you are left with? Let me this be x-axis. This is your y-axis. Only this much portion, and then take the image of this here. This what I mean by plus fx. This what I mean by minus fx. That is this one I'm talking about. This is bit different here. This is for fx less than 0, the graph won't exist. For fx, this is plus minus fx. Let me write it here again clearly. This is plus minus fx. Wait a minute. Plus minus fx. Plus side of fx and minus side of fx. Do not confuse that y and fx are same. Fx is some graph. You are whatever values of fx is coming, you will only take the modulus values. So this if fx is less than 0, it won't exist because this is only for positive side. So y means mod y means plus minus y, and plus minus y means plus minus fx, plus minus fx. So I cannot take the negative portion of the graph that is below the x-axis. Let me take one more example. Serious example. Y equal to, we have x minus 1 and x minus 2. This is the parabola basically of this form. This is your x-axis. This is your y-axis. Some type of parabola it is here. I'm drawing it for you. You will neglect the fx portion which is less than 0. This portion will be neglected. So now for mod y, you see this one. For mod y equal to x minus 1 and x minus 2, now you will have this graph like this. This is your x-axis, this is your y-axis. This much portion of the graph would be there. You leave the remaining portion, and then you have your this much portion. This much portion. Take the image of this about the x-axis. This will be somewhat like this, and this will be somewhat like this. Y equal to sine x. You already know this graph is like this. This is your x-axis and this is your y-axis. And these are your plus 1 and minus 1. Now you know this graph goes like this and like this. And this graph here goes like this and like this. If I write mod y equal to sine x, you will have to remove this portion, this portion below the x-axis. Now, and you will take the image of this portion. You will take the image about the x-axis. Image about, that means it will become like this. See, this is your line. This is your line y equal to minus 1 and y equal to plus 1. This is your line y equal to plus 1, y equal to minus 1, x-axis, and this is your y-axis. So this one portion, this portion will now be reflected here, and it will be reflected here. This portion will be reflected, now this will be reflection here. This portion will have a reflection. This much portion will have a reflection here, like this, some sort of like this. Now, I think I'll do the last one now. This is the 12th one. Yes, I'm doing the 12th one now. 12th one. 12th. Wait. Yes, 12th one. If your, or this is y mod is equal to fx complete mod, right? Fx complete mod. Now, this is, what you do is that if you have an example like this, if you have a curve like this, see, this is your x-axis, this is your y-axis, and your curve is somewhat like this. Curve is somewhat like this. Wait a minute. The curve is somewhat like this. So you will take, because of this mod, first the mod function will take place. First you take the mod function. And this will be, now, this is your x, this is your y. So now you will do, you will draw like this, and this portion, this portion will now come like this, and then this portion. Now you will take the reflection about the, now for mod y part, you need to do the mod y. This is different part. This is, then you are taking the mod of this. This is mod y. Forget about this for the time being. Just see this. Just see this. You will get this type of a function. Now there is a mod y. So now operate on mod y. So now for the mod y part, you need reflection of this along the x-axis. You need reflection. Now see, this was your graph. This was your graph. Wait a minute. Yes, this was your graph. Now you have this way, you have this way, and you have this way. So you take the reflection now. This reflection will come like this reflection will come like this, and this reflection will come like this. Your mod y is mod f mod x mod this whole mod. Now what you do is that take a graph. You know the steps for this. First you do the steps for this. First you do the steps for this. Suppose you have a graph like this. This is your x-axis. This is your y-axis. You take the graph like this. No problem. Now this inside mod means you will neglect every portion on the x-axis and take a less than x-axis. You will neglect करोगे सारे portion जो x less than 0 से है. X less than 0 you will neglect. So now you take the image along the y-axis. This will now become, this will now become, this is your x, this is your y, this is your x, this is your y. Now this is the part left. You will take the image like this. Now mod, this outside mod, now this outside mod, this thing will remain as it is. The outside mod, this will remain as it is. Now see, now this has become, this is actually y equal to mod fx mod. Oh, wait a minute, let me rewrite this. This is f mod x and then mod this much. Now when I will, now what I will do, I'll put a mod on this, mod on y. So mod fx, mod on this, and a mod on this. So now this graph will now become like this. See, this is your x-axis, this is your y-axis. The graph is like this and like this. Now you will have a reflection because of this mod here. You will have to take a reflection about the x-axis. So this will be like this, and this will be like this.